This video is for my Algebra 1 class. It's over Lesson 41, Finding Rates of Change and Slope. So, ladies and gentlemen, with your handout, you should read through the objectives. Remember, treat this kind of like a checklist of things that you should be able to do after this lesson is done. So vocabulary here, we have rate of change. So rate of change is the ratio of change in one measure to change in another measure. Rate of change can also be thought of as slope. So when we're making a connection to graphing, your rate of change is your slope. Also remember that change can be defined as final minus initial, particularly when math meets science. This is how we often think of change. Change is where we ended up minus where we began. And so slope, the formula for slope is often symbolized with a lowercase m. Don't ask me why. I actually don't know why it's symbolized with a lowercase m, but it is. And then it is defined in a few different ways. One way is rise over run. So how far it's going up or down over how far it's going left or right. This can also be defined as delta y over delta x. So the triangle here is actually the Greek letter delta, which means change. So, and again, change is going to be final minus initial. So delta y is going to be your final y value minus your initial y value. So y sub 2 minus y sub 1. Or in other words, your second y value minus your first y value. And then so the run is delta x, so same idea here, x sub 2, the final x value, the second x value, minus x sub 1, the initial x or the first x value. And so depending on how we are trying to find slope, we can use any of these formulas here. Typically we stick to rise over run or the y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So if we think about slope in terms of rise over run, or delta x over delta, or delta y, excuse me, over delta x, that can give us some insight into what our slopes mean. So if you take a look here at our chart, I've got the chart set up here, so that way when we're thinking about rising, so up and down, we go up and down in our chart. Excuse me, when we're thinking about our run, we go left and right. And so we'll see kind of what happens here with our slopes. So if we start, so first of all, one of the things you may notice is in your handout, all this yellow here actually should be red for you. Unfortunately, it didn't print correctly on my printer, but yours should be red. So let's take a look here. We're going to start in the top right corner. So top right, so we're going up and right. So up is a positive and right is also a positive. So if you have a positive over a positive, that's going to give you a positive answer. And so if our line is moving up and right, that's a positive. Okay. Now I'm going to flip to the opposite corner. So negative would be, going down would be a negative, going left would be a negative. So if I'm going down and left, well, a negative over negative we also know is a positive. So down and left also makes a makes a positive slope. So up and right, down and left, and you can see here they can be part of the same line. So grab your yellow for this. We're going to highlight the results and those lines. So as we look at this line and we move, as we read from left to right, if you can imagine having a little person who's walking along this line here, you would say that that little person is moving uphill. So a positive slope is basically telling us as we move left to right, this line is going uphill. All right, let's try out our other corners then. So up would be positive, but left would be a negative. So positive divided by negative is a negative. So up and left is a negative slope. If we come down to this corner over here, so down would be a negative, but right would be a positive. So a negative divided by a positive would still give us a negative. So down and left gives me a negative. Now, if you would please grab your pink highlighter for that one. So a negative slope sends us either up and left or down and right. So again, if you imagine a little guy walking along this line, excuse me, as we move from left to right, we would say that this negative slope, he's walking downhill, which should make sense. If a positive slope is uphill, a negative slope should be downhill. Okay. So let's look now in between. So if this is up and this is down, then 0 in the middle would mean no change. So 0 for your numerator means that we're not going up or down at all. So if we have 0 over a positive, like 0 over 5 or 0 over 7, sometimes it helps to actually put numbers in and think about what you do. Well, if I had 0 out of 5, 0 out of 7, I just have 0. So if we don't go up or down at all, but we just go to the right, that's what that's looking like. And so over here, if I had 0 over a negative, though, it's going to be the same thing, because 0 over negative would just be like 0 over positive, except you have negative sign. But then if it's 0, negative 0 is just 0. So if we don't go up or down, but we just move to the left, we're still going to have that slope of 0. And so for this one, if you'd grab your blue, please. We're going to highlight this one in blue. So if you take a look at what does a slope of 0 then mean for us? Well, it means that we're not going up or down at all. We're just going left and right. So a slope of 0 tells us that this line is horizontal. So positive means uphill, positive slope. Negative slope means downhill. A slope of 0 means we're not going uphill or downhill. It's nice and level. That's horizontal. And then finally, in the middle here, we'll start here, where if we just go up, but no left or right, well, anything over 0, you can't have 0 in the denominator. That's undefined. And so this is just going up. And then likewise, a negative over 0, so if we're going down, but we're not going left or right at all, this is also undefined. And so for this one, let's grab our purple highlighter. So a undefined slope generally means that the line is just going up and down. It's not going left or right at all. There is no run. It's just going up and down. So this would be a vertical line. I suppose I should write line there. Well, so vertical line, horizontal line. All right, so now I said generally on purpose, because I've left out the middle section here. So 0 over 0 would also be undefined. But let's consider this. If we say 0 over 0, this means 0 for my rise means I'm not going up and down at all. 0 for my run means I'm not going left or right at all, which means I haven't moved at all. So if you have 1 point and you don't move at all, you're still at that 1 point. So in a situation like this, if you have 0 over 0, this is just a single point. This is not a line. And if it's not a line, then undefined in this case really isn't describing a slope. So in order for the undefined to actually tell us that we have something vertical, the numerator has to be something other than 0. We have to have some sort of movement. Otherwise, we just have a single point. So undefined usually means vertical lines as long as they're not the same point. Okay. And so we're going to go ahead and flip this over to the next page, and we're going to take a look at how to find some slopes. So first of all, as I look at this first example here, one of the things that stands out to me is if I imagine a little guy walking along this from left to right, well, he'd be walking uphill. So even before I do anything else, I know that my slope is positive. So for finding a slope on a graph, one of the easiest things that you can do is just to think rise over run. So you want to look at the rise, you want to look at the run. It really doesn't matter what order you look at them in as long as you put them into the formula correctly. So for example, I'm just going to take 2 points, and let's say I want to go from this point to that point there. One way I could do that would be to go to the right 2. So to the right 2 there, that's a positive 2, because right is positive. And then I would have to go up 1, 2, 3. Up is a positive. So when I put this together for my slope, though, make sure you put it together in the right order. So m, slope, would equal, and remember it equals rise over run. So the rise here out of these two would be the 3. It's the up-down number. The run would be 2. And generally speaking, we don't write slopes as mixed numbers. So you could either change this into a decimal as long as it comes out as a nice decimal, so 1.5 would be an option. Or honestly, you could just leave it as the improper fraction and move on. So that would actually be acceptable there. All right, we're going to find this slope again. So we already know it's 3 over 2, but I want you to just look at it from a couple of different ways. This time I'm going to look at, what if I went from this point to that point? Well, I could do that by going down 3, so that'd be a negative 3, down's negative, and then I could go left 2, so left is also a negative. So what if I tried to find the slope going that way? Well, no big deal, because slope is still going to equal rise over run. So the rise here just happens to be a negative 3. The run now is a negative 2. Well, a negative over a negative, those are going to cancel. And so, excuse me, we're still going to end up with our positive 3 halves. We just have to cancel those negatives. We're going to do this one more time, just because I want you to see the flexibility that we have here. You just need to choose 2 points. So what if I choose this point up to that point over there? So I'm going to skip this one this time. So if I did that, I might say that I have to go up 6, so up is a positive, and then I have to go right 1, 2, 3, 4. 4 is also a positive. So if we look at the slope going from this point to that point, then my m would equal a positive 6 rise over a positive 4 rise, which then I could reduce that by dividing each of those by 2 to, again, 3 halves. So what you see here is that it doesn't matter which 2 points on the line you choose, any 2 points will get you the correct slope. All right, now we're going to take a look at how to find slope using that y sub 2 minus y sub 1 formula. So in this case, you need to think through 2 points. So you need to choose 2 points, excuse me. So I'm going to make my first point, my x sub 1, comma y sub 1. I'm going to make that this point right here. So that point right there is 1, comma 3. And then I'm going to make my second point, so x sub 2 minus y sub 2. It's the second point, so it gets the sub 2's. I'm going to make my second point this one down here. So this one down here is a negative 3, comma negative 3. So x sub 1 is 1, y sub 1 is 3. X sub 2 is negative 3, y sub 2 is negative 3. So if I use my formula, remember that this is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So it's just a matter of picking out these values from your 2 points. So you notice in the numerator are both of the y values. we take the second y value minus the first. So in this case, it's going to be a -3 minus the 1. And then on bottom, it's the second x value minus the first x value. So here's my x values, and it'll be the second. Oh, I made a mistake in the numerator. Sorry about that. So, right, y sub 2 is -3. Y sub 1 would have been 3. Sorry about that. All right, so back to the x's. So the x's are my 1 and my -3. So the second minus the first. There we go. Now, -3 minus 3 is a -6. -3 minus 1 is a -4. And then if we divide those both by -2, that'll reduce down to the 3 halves we got each of the other times. All right, so next example. So again, if we imagine a little guy walking down this line from left to right, just like we read, he'd be going downhill. So when we're all done, we expect to get a negative slope. So once again, maybe I just choose to kind of go left to right, just like our little guy would be walking. So if I do, this point is going out 4 to the right, but then it has to go down 1. So +4 to the right, -4, or -1 to go down. And so when we put this together as our slope equals the rise first. So the rise is the up and down. So that'd be a -1. And then the run is the left to right. So that's a +4. Well, if you have a negative divided by a positive, that's a negative. So a -1/4. All right, we're going to do this one just one more time. So if I were to go from here, let's say back to that middle point, this would travel left 4, left is a negative, and then it would go up 1, up is a positive. And so if we look at it that way, then the slope would be a +1 because we're going up 1, and then the run would be a -4 because we're going left. And so again, a positive divided by negative gives me a -1/4. So pause the video and try this one out for yourself. All right, hopefully you've given that a shot now. So probably the easiest way to do this would be to think left to right. That's often the easiest. So I'm just going to choose this point to that point. You might have chosen different ones. That's fine. So if I go this point to that point, I'm going to go up 2, that's a +2, and then right 1, that's a +1, which means my slope here would be a rise of 2, up down is 2, and then a run of 1. Now 2 over 1 simplifies just down to the whole number 2. So this line right here has a slope of +2. So the positive tells me it's going uphill, and then the 2 as a fraction tells me it's going up 2 for every 1 to the right it goes. So we're going to switch gears now here a little bit. So before I gave you the line and I asked you to find the slope, this time I'm giving you a point and a slope, and I'd like you to give me the rest of the line. So if I take a look at this one right here, a slope of -2/3, this is my rise over run. Now what I want to do here though is what gives me a negative. What gives me a negative is either a negative divided by a positive or a positive divided by a negative. So if we think that through, that is then the two directions that we're going to go. We're either going down and right, or we're going up and left. And so if I follow this first one here, I'm going down 2, so down 2, 1, 2, don't actually make a mark there, just leave your pencil there. And then +3 tells me right 3, so 1, 2, 3, and now I'm going to make my next dot. And then we can do that again, so down 1, 2, right 1, 2, 3, there's another dot. Or we can reverse it and go with this. So I could go back up and go 1, 2 up, and 1, 2, 3 left. So up 2, left 3. All right, that's about all the points that I can fit on this space right here. So I'm going to go ahead and draw my line through those points. And it's good to use your slope to get as many points on your coordinate plane as you can. Just it creates greater accuracy when you go to draw your line. If you just do 2 points, unless you're using a ruler, you're going to have a lot of human error. So as many points as you can on your coordinate planes. Down here, let's take a look at this one. So here's my point, but this one has a slope of 4. Now, since it's a whole number, we kind of want to think of it like this guy over here. So just like 2 was really 2 over 1, I want to think of 4 as being 4 over 1. Okay. So 4 over 1 is going to tell me to go up 4, because that's my rise, and right 1, because that's my run. So from here, 1, 2, 3, 4 up, and 1 to the right. And if I try to go 1, 2, 3, no, I'm not going to have enough space on there for another point in that direction. So that's fine. We got 1. With a slope of 4, that's going to happen. And so now, here's the thing though, we can reverse that because remember, our slope is positive. So what will give me a positive answer? Well, a positive divided by a positive will give me a positive. But how about a negative divided by a negative as well? And so if we look at the slope from this perspective, this will be a negative 4 rise, so down 4, and a negative 1 run, so left 1. So if I go down 1, 2, 3, 4, and left 1, I get 1 more point on my coordinate plane right there. So I'm going to go ahead now and draw my line. So slope of 4 you can tell is getting kind of steep. So if you look at the line here with the slope of 2 versus the slope of 4, the higher the number, the steeper the line. All right, so again, why don't you go ahead and pause the video and try this next one out for yourself. And then when we come back, we'll take a look at it together. All right, so let's see how you did. So first of all, we could think of this rise over run. We could think of this as 1.5 over 1. Or, again, what gives me a positive? A negative divided by a negative. Okay, so there's an option right there. So I can go up 1.5 and then right 1. Now, that doesn't put me right where the grid lines meet. So I've got to do my best to try to find that halfway space. And then I could reverse that, go down 1.5 and go left 1. Or there's another option here. You can take this 1.5 over 1, or just this 1.5, and reimagine this as a typical fraction. So multiply this by 2 over 2, or just realize that this is 1.5. So what is that? 3 halves. And of course, if it's 3 halves, that's the same as a negative 3 over negative 2, because the negatives would cancel. And honestly, that would probably be the easiest way to go, because then I don't have to deal with the halves. I can just go up 1, 2, 3 and right 1, 2. And then up 1, 2, 3 and right 1, 2. Up 1, 2, 3, right 1, 2. And then I can reverse that, down 3 and left 2. So down 3, left 2. So 1, 2, 3 down, 1, 2 to the left. And there's my line. All right. Next up, we're going to take a look at 2 points. We're going to find their slope, and then we're going to graph them. So we're going to use our formula, m equals, and remember m in this case equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So in this case, I would take my second y value, so my second y value here would be 4, minus my first y value, which would be 4 as well, over my second x value, minus my first x value, 2. So if we simplify this, 4 minus 4 is 0. Negative 3 minus 2 is a negative 5. And so, well, 0 over negative 5 is just 0. So right off the bat, this should register with you a little bit based on the chart we did on the front. A slope of 0 means that something is horizontal. So if we were to graph this, 2, 4 would be right there. And then negative 3, 4, so negative 1, 2, 3, and then 1, 2, 3, 4 up would be right there. And sure enough, if we draw a line through those 2 points, it would need to be a horizontal line. Now, one of the things that you may notice about this horizontal line is that our y values were the same. And this actually leads to the equation of a horizontal line. Horizontal lines will always have a constant y value. Because there is no rise, it's not going up or down at all, the y value is not going to change. And so the equation of the line tells you what y value that is that's never going to change. So the equation of this line is actually y equals 4. So if I had a horizontal line that went through this point right here, if I had a horizontal line that went through that point right there, take a moment, pause the video, what would its equation be? All right, so hopefully you got the equation y equals 2. That's the y value that would always be the same for that horizontal line. Since it's horizontal, it has no rise, the y value is always the same at 2. So in general, the equation sorry, my z's a little off there. The equation of horizontal lines is y equals b, where b is just some number. So very simple equations, just y equals whatever number, y always equals. All right, next example here. So we've got these 2 points. We're going to do just like we did above and find the slopes. So this time my second y value is a negative 1 minus my first y value is 2. And that's going to be all over my second x value, negative 1, and my first x value of negative 1. Now right off the bat here we see minus a negative instantly. Anytime you see that, change it to plus positive. And now as I simplify, negative 1 minus 2 would be a negative 3. And negative 1 plus a positive 1 would be 0. And of course, if it's over 0, that is undefined. And once again, if we think about that chart from the beginning, if we have a slope of undefined, our slope is undefined, but it's not just the same 2 points, or the same point both times, then that indicates that we have a vertical line. And so the thing that we notice with a vertical line is that the x values are the same. So if we were to graph these 2 points, we have negative 1, 2, and negative 1, negative 1. And sure enough, if we draw a line through those 2 points, we have a vertical line. And so the equation for this tells us what's got to be true. Well, that x value always has to be the same. So in this case, the x value always has to be negative 1. No matter which point we're looking at, the x value has to be negative 1, which again should make sense because a vertical line has no run. It's not moving left or right, so the x value is always the same. So just like we did before, let's come over here and let's draw a vertical line through this point right here. So pause the video, take a moment, and try to figure out what would be the equation of a vertical line through this point right here. All right, so hopefully you got the equation x equals 4. Because the x value here is 4, and so on a vertical line it would always have to be 4. So whether it's this point or that point or that point or that point or that point, the x value is always 4 on this vertical line. So if the equation of a horizontal line is y equals b, the equation of a vertical line, or vertical lines, could be described as x equals a. Now a and b are both constants here. So a and b are constants. And then let's just grab our orange here and make that just pop a little bit. And that, ladies and gentlemen, is the end of this lesson.